Hi folks, welcome to your first online session. What I'll do is I'll talk through the PowerPoints and then you'll have a few questions you can have a go at the end. Just to start us off though, see what we did in that introduction lesson, if we have time. Surds odd one out. You should know this from GCSE anyway if you didn't manage to get it done in our introduction lesson. Says which one is the odd one out? Circle the expression in each row that is not equivalent to the others. In the empty square, write an expression that is equivalent to the odd one out. Okay. Right, so what you had to do, I'll just do it with the top one anyway, and get you going. So with root 72, yes, you could put it in most calculators and cheat. A bit of mental maths warm up today. Root 72, you think what square number goes into 72? I wonder. Well, I think 36 does. 36 times 2. And therefore that's the root of 36, which is 6. So it's 6 root 2. That's 6 root 2, that's 6 root 2. Ooh. And then you have to change that one. If you think what square number goes into there, well, it's 4. So it's 4 times 2. Root that's 2 times 3 is 6. So that's 6 root 2. So obviously the odd one out then is this thing. Oops, no, it's not. No rubbish. It's this one. So that's the one we're circling. And in here, write an equivalent to that. Something quite simple, maybe. Ooh, can I think of anything? No, I'm not very quick at this. Something equivalent to that. Oh, well, I'd have to think. A bit too long at thinking. Right, so you have a go at the others while I mess about with that one. I'll pop something in up in a second and see if you can find the odd one out in each of the rows and then an equivalent. Okay, off you go. I'll give you some time. Just so that you don't think I'm completely stupid. To put an equivalent, you could just easily do what's 2 squared. Well, that's 4. So basically 6 times 4 works out at root 6 times 4, 24. If you try that, that would be the same as that. Anyway, shut up and finish. You can finish. Okay, if you need more time, just pause the video and take the time. Otherwise, let's choose the odd ones out. Hopefully you've got them. Oh dear, pen. Right, so next one on the line we should have got, that was the odd one out. Then that was the odd one out. On the final line, it was that one that was the odd one out. I hope you managed that and found some equivalents. As I say, you could pick the obvious way to do equivalents. We know 6 squared is 36. So 36 times 10 would work, which is root 360. If you try that, that'll get you back to that, and so on. Okay, right, let's start today's lesson. Surds and Indices, lesson 2. The aims of today is to be able to rationalise the surd denominator, to be able to apply surd operations to solve problems, to know and be able to use the basic index laws, and to know and use the zero and negative index laws. You may have seen some of these before. I have given you, perhaps, I hope, a handout for this lesson, which you can use to fill in if you like. It makes it a little bit quicker if you're just filling in my handout, although I've no objection to anybody who wants to write their own notes entirely. From the next PowerPoints onwards, you'll have been given in the homework email the attachment to print out for these handouts. We're not meant to print too many things out. So if you want to use my handouts for lesson 3 and not so on, I'm afraid you'll have to print out the handout yourself and then write on it. Okay, anyway, let's get on. Hope you've got your handout ready for this one if you're using it. Rationalising a denominator. When a fraction contains a surd as the, if you think about it, as the denominator, we usually rewrite it so the denominator is a rational. A rational number, in other words, get rid of the surds. This process is called rationalising the denominator. No big surprise. For example, here we've got one. So we need to rationalise the denominator, get rid of the square root off the bottom. So to do this, what we get rid of root 2 is timesing it by root 2. But to keep it the same fraction, you can't just times by root 2 on the bottom. You need to also times by root 2 on the top, because what you're in fact timesing by here, this number we're timesing it by, is in fact 1, isn't it? So we're not altering the number, we're just getting rid of the surd on the bottom. So what we will get there is 5 root 2 over root 2 times root 2 is 2. Now, if you've got a calculator, you might find that a lovely one like this, it rationalises the denominator for you when you actually put it in. You can try it if you want to. ABC button or this fraction button, shift root 2 and see if it actually rationalises it for you. Yes, mine does anyway. This fancy one that we're in fact asking you to buy would do it for you, and I think many others would at this stage. But it's good to know how to do it by hand. Oops, I've written over that, so that's rubbish. Can't move it, sorry. Right. It says simplify the following fractions by rationalising their denominators. So you can pause the video at this point and have a go yourself. Please don't just use the calculator, it spoils the fun of mathematics at this moment, but have a go yourself and see how you get on. Okay, you're probably unpaused by now, so here we go. Let's just do these answers fairly smartly, see what you've done. So hopefully you did 2 root 3 times root 3 over root 3, and you end up with 2 root 3 over 3. The next one, we should put some equals in there, shouldn't we? The next one, hopefully you did root 2 over root 5 times root 5 over root 5. That gets rid of the denominator on the bottom because you just get 5. Rooting these together, we've hopefully got root 10. Left it there. Next one. 3 over 4 root 7. Now you can times top and bottom by 4 root 7, but it just gets the the number's too big. So if you just times by root 7 over root 7, nothing wrong with timesing by putting a 4 there and a 4 there. Just makes the numbers big and you have to cancel them down afterwards. But doing it this way, you'd end up with 3 root 7 on the top and 4 times 7 on the bottom. If you know 4 times 7, I think it's 28. We've got 3 root 7 over 28. Final answer. If you did it by 4 and 4, your answer will cancel down to 3 over 28 if you've done that. Right, what's next? Rationalising denominator further. When a denominator involves sums or differences between surds, we can use the fact of the difference between two squares. If you think of the difference between two squares, I've done this a lot, I'm sure, whether it's numbers or values in there, a take b times b, a plus b, then you end up with the two things squared and a subtraction between the difference of two squares. So basically, if we're doing it with roots things, the roots, when you square a root, you get the number. So it's a good thing, that, because it just gets rid of all the roots. So let's have a go with an example. This one. So what we're going to times by is rationalise the denominator. So we had a minus here, then we need a plus. The same thing, but with a plus in it, and that'll get rid of the roots. So here, done it for me. We times in the top and bottom. This thing we've got here equals, because basically we times in by 1, remember. This thing here is only 1. We're not altering the fraction. So 1. Right, so what do we get if we times this out? Well, we know on the bottom, because we're doing this thing, like difference of two squares thing, we're going to get here, basically, root 5 squared, which is 5, and minus 2 squared, which is 4. So that's what the bottom's going to become, and 1 times the top and the top, so we just get root 5 plus 2 on the top. And that ends up, because that's 1, is just root 5 plus 2. Simple. Here's another. It says it's more difficult. Examples may include surds in both the numerator and the denominator. What fun. Right. Have I done any more on this one? I don't think I have. So straight writing it down. So we've got 2 root 3 take 1 over root 3 plus 1. What we're going to do, I'm not writing it again. We're going to times the top and bottom by the same thing that's on the bottom there, but with a minus in the middle. So remember, we can't alter it, we're only timesing by 1. So what we'll get on the bottom is root 3 all squared, which is just 3. Take away 1 squared, which is 1. And on the top, we've got a bit more to do. We'll put brackets here. Remember to do it in the sort of the bracket way. So we've got 2 root 3 times root 3. Well, that makes 2 times 3, doesn't it? Which is 6. Then we've got that times minus 1. So we've got minus 2 root 3. And then we've got 2 root 3. Oh, we did that one. So we've just done that times that. And I've just done that times that. So now we're going to do this one times this one. So we've got minus root 3. And then that one times that one gives us plus 1. So equals here. So on the bottom we've got a 2. On the top we've got 6 plus 1, which is 7. And we've got 2 of those and take away another. So we've got minus 3 root 3. And that is it. Job done. You do need to be able to rationalise denominators. They sometimes want you to show that in the exam. So don't rely completely on the calculator doing it for you. Because they say show working, and in exams, if it says show working, and you put it in your calculator and write down the right answer, they don't give you the mark. Be warned. They need to see a method to get the marks if it says you must show how you did it. And that's what they do in these exams. They say show. Right, move on. This one, show that this can be written in the form that, where A and B are integers, hence find the values of A and B. Oh, no squirrel. Right. So what are we going to times the top and bottom by? Oh gosh, here comes the cat. Oh, come and meet the new students. This is Squirrel, the cat. Right, he'll sit on my knee. Right, times the top and bottom by. I'll just let you see it better. There we go. Right. Times the top and bottom by. We'll get there eventually. Root 6 plus 3. Hopefully you've done that already. Oh, plus root 3, I hope you put. This gives us, so we're going to have root 6 plus 3 on the top over root 6, take root 3, that's a root on this one, times top and bottom by root 6 plus 3 over 6 plus 3, denominator easy. Root 6 is going to give us a 6, and we're going to be taking away, oh, it should be a root on that one. Should be a root on that one as well. Lazy. Root 2, 3 times root 3, so we're minusing 3, aren't we? And on the top, we've got right mess here. Root 6 is 6. Root 6 times root 3 is plus root 18. And then we've got another plus root 18. And then we've also got a plus 3. Root 3 is a plus 3. So what have we got? We've got 9 plus 2 root 18 over 3. And then we know root 18 is 9 times 2, isn't it? So and therefore what we're doing now is we've got 9 plus root of 9 is 3. 3 times 2 is 6. So that. So dividing by 3, each of these can be divided by 3. So 9 divided by 3 is 3, and 6 divided by 3 is 2. So we could write it like that. And that's how we want to try A plus B root 2. And that's what we've got. Our A is 3, and our B is 2. Okay. Fill that in if you can on the bottom. So it says on whiteboards, I know you've got the whiteboards if you want to use them. You can have a go at trying those 3 questions. All about what we've just been doing. Try them by hand rather than calculator. Give it a go. Pause the video. Okay, you might have unpaused. So here's the answers. Number 1. Number 2. Will come eventually. There's the final one for number 2. No, it's not. Get there eventually. There's the final one for number 2. And then number 3. I'll be the final answer. Scroll. You know to go. And there you are. Have you got those? Let's hope so. Right, an application of all this, if it's put in an applied question, might be, what's it say here? Find the length of the third side in surd form. So you should have met Pythagoras. Should be good with that. So you know that from Pythagoras, a squared plus b squared equals c squared. Hopefully you know c is the longest side, which seems to be that one. So what we've got to do here, we've got root 27, that's the length, got to square that, plus some unknown, which we want to find. Should we call it x? You call it b if you wanted. I'll call it b. Whoops. B squared equals this thing squared. So root 27 all squared is 27 plus b squared, and that thing squared is 121 over 3. So it's just 27 of that thing. So b equals, and does 121 divide by 3? I wonder. Maybe it does. See my calculator. Can't do it when I've got students to do this for me. Terrible. Come on, machine. Sorry, I'm there. 121. No, it doesn't. So b squared, 121 over 3, take 27. Gives me 40 over 3. So when I square root that, oh dear, if I was having to do this by hand, this is quite a faff, isn't it? And that equals, so we know that that's, doing a funny square root now, 4 times 10 over 3, and square root of 4 can make us in square root top and bottom, so that becomes 2 root 10 over root 3. To get rid of the third, times top and bottom by root 3. So you end up with 2 root 30 over 3. I think that's our final answer, unless I've gone a bit wrong there. Just check that. No, that agrees with the calculator. Super. Okay, so we're going to have an hour stop from the Surds. You might get some Surds in your homework email to do. So good luck with them. And indices and notation rules, we need to know about those too. So a times a times a times a is in fact a to the 5. When we multiply two terms with the same base, indices are, think of that as a 1, a 1, a 1, a 1, a 1. What have we done with all those ones? Well, we've added them. Just above there, I didn't say that. A value is called the base, and 5 here is called the indice or power. So there's our little rule for this, which seems to have got in the way of me writing added. It says a to the m times a to the n equals a to the m plus n. We've got an example again of that. That would just be add the powers times in a to the, oh, a to the 4, idiot, a to the 6. Right, when we divide two terms, didn't divide. Two terms by the same base, the indices are, you can probably see here, subtracted. So an example of that would be perhaps that, we have to still do the divide with the numbers. 8 divided by 2 is 4, but because it's terms, 8 to p to the 6 divided by p to the 4, we just divide, we do take away. So that is 2. And if you want to see it in full, basically it's 8 P times P times P times P times P. And we've got that 1, 2, 3, 4, 5, 6 over, because the over is same as divide, 2 times P times P times P times P. So they end up cancelling. And you're left with 8 divided by 2, which is 4, and P squared on the top. When a term is raised to a power, then the result raised to another power, the powers are multiplied. That was a mouthful. In other words, this says it a bit much better. A to the m to the n becomes a to the m times n. Examples. 2 examples here. So this one is just y to the times them together, 6. And this one may be slightly harder. P to the 1 becomes P to the 1 times 4, which is P to the 4. And Q has got a power of 2, so it's 2 times 4 is 8. Yes, hopefully you knew all that. Right. Have a go at those on your whiteboard or on a piece of paper somewhere. Pause the video and have a whirl. What fun. Okay, probably unpaused. And here come answers. Number 1, number 2, and number 3. Hope you got them. Right, next. 0 and negative index. Look at the following division. Y to the 4 divided by y to the 4. Well, you should know that that's in fact 1, isn't it? Common sense. But using the indices rule, y to the 4 divided by y to the 4, what would we do? Well, we'd subtract the powers, wouldn't we? 4 take 4. Oops. That's going to pop up or not. So here, using the indices rule, we get 4 take 4. And that is in fact y to the 0, isn't it? Yeah. So hence from that, y to the 0 must be in fact 1. So anything to the power 0 is 1. Now this division. So what can we get from this? So now this division. So right, if you were doing that longhand, here we go. B squared divided b to the 4, cancel them off. So we get 1 over b squared. Use the indices rule though. We'd subtract the powers, so we get 4, 2 take 4, which is in fact b to the minus 2. That means that b to the minus 2 is in fact the same as 1 over b squared. And then in worth noting, anything to the power of a minus can be written as 1 over the same thing, but to the power of positive, whatever it was. That's a rule to remember if you didn't know already. Right, so you can have a little go at these if you want. You can either pause, have a go, and then I will run over them hopefully fairly swiftly. Okay, unpaused. Right, 1 over u. This one, 2 doesn't drop to the bottom because it's not to the power of negative. It's 2 stays on the top and you've got n to the 4. This one, x squared still on the top, but that's a negative power, so it's written like that. And this one, 5a on the top over 3 minus b all squared. These are in, write these in negative, they're a fraction, so that one can be written as 2a to the minus 1. This one, x to the 3, y to the minus 4. This is p squared bracket q plus 2 to the power minus 1. And the last one, fit this one on, 3m bracket n squared minus 5 to the power minus 3. Hope you got those or understood them when I went through them. Mixed problem. Says 3 minutes to try first. So please pause this and have a go yourself before I do them. Okay, unpause. Some of these are quite complicated, really. So this one, we got that bit, and we've got, I'll put it on the top now, times 1. This squared gives you 9a squared b to the minus 2. Now get rid of that because it's a minus power, you can put it back on the top. I would anyway. So 4a squared, b times b squared is b to the 3 over 9a squared. They cancel out now. And you finally get 4b to the 3 over 9. You can do it other ways, but that's one way. Right, this next one. What have we got here? We've got p, q. I'm going to drop the r to the bottom. So I've got r squared, q squared. Now it's a divide. Fractions divide, you can change it to a times and flip it, can't you? So you'd have q on the top and this q, and r is the minus 1. Oh, I'll leave it there for just not complicate matters at the minute. Right, so look what's going on here. We've got, I've got a q and a q, haven't I? Get rid of that. Goes into that once, and that goes into that once. I've got a q there, I can get rid of the squared. So my next line might be just p over r squared q times, no, because that's an r to the minus 1, it can pop to the top. So it's r over, and these are just cancelling out over 1. Can then write it, if you like, as pr over r squared q. That r cancels with the squared, so we're just left with p over rq. And that's the final answer. Bit tricky those, so don't worry if you didn't get them. I'll have some practice in a bit. It says here, complete the puzzle. Well, we don't do puzzles now because we can't touch them. Or we have to wipe them down and we haven't got them online anyway. So it says then do worksheet. So have a little practice at these questions. You don't have to do them all. Just get comfortable where you can do them. So if you're brilliant at them, just try 3 and move on. But if you struggle a bit, make sure you have some good practice. So you might have a worksheet with these attached, or you might just want to pause this video, go back on it and look at the questions. There is a section B. It'd be a bit harder using those negative indices. And then if you move on with this, you'll see you've got the answers. So that's enough from me for lesson 2 of Surds and Indices, and I shall see you for the next online lesson. Bye bye.